Okay, so let's finish this video. Step number 2, question number 2 says to simplify. So here's the deal. Sometimes they ask you to verify. That's coming up in 4.2. When they ask you to verify, you know what your end game is. You know what you're supposed to end up looking like. When they just say simplify, you don't really know exactly what it's supposed to end up like. You just try it and see what happens. So let's try it, see what happens. So if it says to simplify this, a good idea is to break this into sine and cosine language. And so let's go ahead and do that. What is secant equal to? We know that secant is equal to 1 over the cosine of theta. So let's rewrite this into 1 over the cosine of theta. And we know that the cotangent is equivalent to the cosine of theta over the sine of theta. So now we're multiplying fractions together. When you have common factors, one's in the numerator and one's in the denominator, those will divide into each other, giving you a 1. And then you can just multiply. 1 times 1 is 1. 1 times sine of theta is sine of theta. And then this is equivalent to the trig function that we called cosecant of theta. So this is a simplified form of that. Let's try this. The cosecant squared of v minus 1 over the cotangent of v. What in the world should we do with that? Well, I don't know offhand, but I know this much. Do you see this cosecant squared of v minus 1? When I see a cosecant squared, a cotangent squared, a sine squared, a tangent squared, I'm going to try to use the Pythagorean identity. So which one of these involves cosecant squared? So like I said, I don't typically memorize all those. I just memorize this one, that the sine squared plus the cosine squared is 1. And from that I can come up with the others. Sine divided by sine is 1. Cosine divided by sine is the cotangent squared. 1 divided by sine is cosecant squared of v. And so cosecant squared of v is in this one, and that's what I'm looking at. Well, you know what? Let's see. What if I subtract 1 from both sides of this? Let's do that. Cotangent squared of v is equal to the cosecant squared of v minus 1. Do you see this? Cosecant squared v minus 1 is equivalent to the cotangent of v. So I'm going to rewrite this as the cotangent squared of v divided by the cotangent of v. And what I understand this to be is the cotangent of v times the cotangent of v. So if I want, this is squared, but if I decided to write it like this, what I can see is I can divide one of these into one of these, and I'm left with just the cotangent of v over 1. And that one's simplified. All right, let's look at this one. What should we do here? I don't know exactly, but I just start trying stuff. Do you see how this is sine x plus 1 squared? I want to demonstrate how to properly square this. If I have a plus b squared, a plus b squared, this is the same thing as a plus b times a plus b. So if I were to distribute the a to both terms, I would get a squared plus ab. And then if I were to distribute the b to both terms, I would get b times a, or ab again, plus b squared. I get a squared plus 2ab plus b squared, which is what I will have every time I square something. I have a plus b squared. So this is equivalent to, I'm just going to copy down the cosine squared of x plus a squared sine of x squared, sine squared of x plus the number 2 times the first thing in the term plus the second thing, 2 times a times b. 2 times sine x times 1 is 2 sine x times 1, which is just 2 sine x, plus b squared plus 1 squared. This is a squared plus 2ab plus b squared. That's what I erased. Okay, that's what I get in my numerator. And then down here, I get, it's the same thing, over sine x plus 1. Okay, I see another Pythagorean identity. I see cosine squared and sine squared. That makes me think Pythagorean identity, and this is the one. Sine squared of v plus cosine squared of v is equal to 1. Cosine squared of x plus sine squared of x is also equal to 1. So this right here, that is a 1. So I'm going to rewrite that. That's going to be 1 plus 2 sine of x plus 1 all over the sine of x plus 1. I'm going to add 1 plus 1 and I'm going to get 2. 2 sine of x plus 2 over the sine of x plus 1. I have done nothing in the denominator the entire time. I just keep copying him down. In the numerator, I can factor out a 2 right there. So over here, I'm going to factor out a 2. That leaves me with the sine of x plus 1 over same denominator, sine of x plus 1. I can cancel this with this. Those are common factors. I get 2 over 1 or just 2 in simplified form. So that is that one. All right, these, let's see. They give us the instructions for number 3. Write the expression in terms of sines and cosines and then try to simplify. So we know let's do the best we can. This one is already in a sine. I don't need to rewrite him. Secant, though, is equal to, this is the sine of x. Let me do different colors so we can see where the work begins. This is the sine of x, the sine of negative x, times 1 over the cosine of negative x. But we saw those negative properties, right? We know that the sine of negative x is really equal to negative sine of x over cosine of negative x is really equal to just the cosine of x because it's an even function. So we know that negative sine of x over cosine x is the same thing as negative tangent of x, and that simplified to that. All right, let's look at this one. Cosine does not need to be rewritten into anything else. He's already in cosine. Sine does not need to be rewritten into anything else. It's already sine. Tangent, let's rewrite tangent into the sine of u over the cosine of u. All right. So I can put this over 1 if that makes me feel better, and it does. So now I'm going to rewrite this. I'm going to multiply these fractions together. So this is the cosine of u plus the sine squared of u over the cosine of u. Now, here is something else when you're like, boy, I don't know. Can I do anything with this? What can I try? Here is something that's a good thing to try. When you have a fraction and a whole number, sometimes it's good to make them both fractions and add them into one fraction. So let's try that. We would need a common denominator before we could add fractions. So right now, I'm just making a room on my board, and I'm just going to copy over that expression. So this next thing I write down, I'm just copying this down. So this is going to become the cosine of u plus the sine squared of u over the cosine of u. Currently, I can put that over a 1. He doesn't have a denominator other than 1. But if I want to get a common denominator, I need to multiply this by the cosine of u over the cosine of u, because this is really the number 1, and that's what's legal. So then cosine of u times the cosine of u would be cosine squared of u over the cosine of u plus sine squared of u over the cosine of u. These have a common denominator. Now I can combine them into one fraction. This becomes the cosine squared of u plus the sine squared of u over the cosine of u. But this, I recognize, I've seen that. That is important. That is the Pythagorean identity. And sine squared plus cosine squared is 1, but also cosine squared plus sine squared is 1 because that's just commutative for addition. Same thing. So this is really a 1 over the cosine of u, which can be rewritten into the trig function of secant of u, and that's that one right there. All right, last one. Break everybody down into sines and cosines and see what happens. So here we go. Cosecant is 1 over the sine of theta. Secant is 1 over the cosine of theta minus cosecant 1 over the sine of theta. Cosine is just cosine. All right. Let's see what happens here. This is really a 1. If I multiply fractions, multiply the numerators. 1 times 1 is 1. Sine theta times cosine theta is sine theta. times the cosine of theta minus 1 times cosine is cosine. Sine times 1 is sine. Get a common denominator of sine and cosine. Let's try the same thing we did before. Let's see if it works. See if it helps us. Get a common denominator of sine times cosine. So I'm going to need to multiply this by a cosine, but if I multiply it in the denominator, I have to also multiply the numerator because that is a 1 and that's what's legal to multiply by. So we get 1 over the sine of theta times the cosine of theta minus cosine times cosine is the cosine squared over sine theta cosine theta. Now they have the same denominator. I'm going to work this way to give myself some room. Okay, ready? I can write that as one fraction. So this is 1 minus the cosine squared of theta over sine theta cosine theta. All right. This looks kind of like maybe I can do something with it, and I can. Remember this guy? Sine squared of x plus cosine squared of x is 1. What is 1 minus cosine? If I subtract cosine from both sides of this, I get this. And so this is another way of saying the sine squared of something. So this is equal to the sine squared of theta over the sine of theta times the cosine of theta. All right. We know that this is just sine theta times sine theta. So I can cancel this with one of these. This just becomes a sine of theta. So this is left with the sine over the cosine. And this is known as the tangent of theta. So let me just check my notes real quick and see if I'm happy with that guy. And where I work this out to make sure, what did I say? This would end up being, yep, this would end up being, yep, this would end up being, yep, this would end up being, oh, I've erased it. I think that's okay. All right, I think that's good.